Welcome to the Warwick Christmas Lectures. Travel back in time with Dr Farzana Meru to a time before our planet was formed and find out about how planets are made.
Hello everybody, my name is Dr Farzana Meru and I'm an astronomer working at the University of Warwick. Astronomers consider space, and we are going back in time right here in our solar system to think about what it was like a long time ago. 4.5 billion years ago, you and I didn't exist. In fact, the Earth and the Moon didn't exist either. This is the area of astronomy that I specialize in. Solar systems before they are fully created and before planets have formed. So, 4.5, in fact 4.6 billion years ago to be exact, we would have had our sun, although it would have been a lot younger. And around this, there would have been a disk of gas and dust. Now, if we dial back the clock even further, we can think about how this disk formed. You would have had a big cloud of gas and dust, and it would have been spinning around and around. Astronomers like to use the word rotating. Gravity would have been pulling parts of this cloud together, and you would have ended up forming stars. And out of this cloud of gas and dust, you would have formed disks around those stars as well. So we have a disk of dust and gas swirling around the star, and we call that a protoplanetary disk. And protoplanetary disks are what I study. So now you're wondering, how does the disk turn into planets? The main way in which planets form, there are various theories, but the main way is when the dust starts to come together. So the dust and gas swirling around the central star, and when they are really small, the dust particles will collide and they will stick together. Now, if you're interested in really digging in deep to this stuff, maybe studying physics at A level or considering a degree in physics, you might like to investigate something called van der Waals forces. Because when the dust is really small, gravity doesn't play a huge part at this stage. The dust actually sticks together by van der Waals forces. Now, for the rest of us, we can simply consider that the pieces of dust are sticky because of some complicated force. And so they stick together, and eventually that dust becomes larger and larger as more and more dust sticks onto it. And then as it gets larger and larger, you end up getting this really big object. Now, this process of dust sticking to it happens over and over again until you get to a stage where you have a big rock, about 1 kilometer in size. That's about the size of a small town centre. And that's called a planetesimal. Now, at this stage, this big rock is sufficiently massive that gravity is really quite strong, and it will start to accrete. That's drawing in lots of dust and some gas onto it as well. It will get bigger and bigger, and that's how you might eventually form a terrestrial planet, like the Earth or Venus or Mars, big rocky things. But if it can get big enough, then it can attract a whole load of gas onto it, and it will undergo a process that we call runaway gas accretion, where a huge amount of gas just suddenly accretes onto the planet and you end up with a giant planet. Now, whether or not you manage to form a giant planet depends on a few factors. One of them is how long the disk lasts, because if the disk doesn't last very long, then the planet doesn't have very long to form, because it takes time to do all of this. Now, the disk lasts for somewhere between about 3 and 10 million years, but it can take a few million years for a planet to form. So it's really a race against time to form these planets, because we know from observations that these disks don't last long, so we've got to do this quickly. So that's the process of planet formation. Now, is that the end of the story? Well, there's a lot more actually, and in reality, I'd say it's only just the beginning. I could leave this as a cliffhanger, but then that's not nice to leave you without knowing over Christmas. So, what happens next? The planets undergo this whole stage of evolution where they will interact with the disk. They might end up hoovering up parts of the disk where gas and dust come onto the planet, and they will carve gaps in the disk. It's quite likely that some of the disks that astronomers are observing have real planets in them. That's incredibly exciting. So these planets will move around in the disk. There's loads of chemistry going on in the disk, and in different parts of the disk, the temperature and the pressure is really different. After about 3 to 10 million years, the gas in the disk is gone, and all that's left of the disk is a lot of dust. This is called a debris disk. A planet will start to sculpt or even shape the disk, and it might even end up shaping something like the asteroid belt or the Kuiper belt. So after this, you might also get a lot of collisions happening where there might be giant impacts, where the terrestrial planets that we were talking about, they don't fully form in the protoplanetary disk stage, but they might end up colliding with other objects, other planets, other protoplanets, and then you'll end up seeing craters on those planets. A bit like what you see when you look at Mars and the Moon. They have examples of craters on them. And so there's all sorts of dynamic activity going on, even once you've lost the gas in the disk. And so what we see now in 2020 all around us is our nice, calm, stable solar system. But it hasn't always been like that, because planets can interact with each other and change one another's orbits as well. But what we see now is a relatively stable system. So if you just imagine, our solar system has been around for 4.5 billion years, and I'm saying it takes somewhere between 3 and 10 millions for that protoplanetary disk stage. That first 3 to 10 million years is the stuff that I do. And then there's all this stuff from 10 million years to 4.5 billion years that I've only just briefly touched on. So you have the star formation phase, then you have the planet formation phase where planets form in protoplanetary disks. And after that is the debris disk stage, in case you want to read and find out any more about it. Now, I'm a theorist. I'm an astronomer, but I don't actually go to telescopes like some astronomers do. I don't look through telescopes, although it is true that a lot of observations are done remotely. There are a lot of exciting telescopes around the world, in Chile, La Palma, Hawaii, and other exciting places. But observational and theoretical astronomy are both very, very important. One type of astronomy doesn't happen without the other. So that might surprise you about my area of astronomy, is that I'm a theorist. I don't make observations, but what I do is to create theories, models, and predictions about what might have happened. But how do we know? How do we know for sure that the theories that I and other astronomers like me come up with are true? We compare our theories with observations, and we also make predictions. Well, for the first time in the last few years, astronomers have actually observed planets in protoplanetary disks, and that's really exciting. We're actually seeing baby planets forming. The ideas about planet formation go back decades, to the mid to late 20th century. And what I think is really exciting is that people made those predictions about how planets form before we had even observed planets outside of our solar system. The early 1990s was when we first discovered an extrasolar planet, and suddenly this field has just exploded. Now over 4,000 planets have been detected. Even 10 years ago, only 500 had been detected. But thanks to dedicated space missions like Kepler and TESS, and missions like Plato that are coming up to help understand these planets, we're really understanding more about how planets form and evolve. The way I look at it is that we are trying to solve a planet formation puzzle. We aren't around for 10 million years to watch the whole process. We're not even around for 1 million years. But we are trying to take observations, looking at different disks and different planets at various different stages of time. And what a theorist like me does is to run lots of computer simulations to try to understand how planets are created and to really try and solve the planet formation puzzle.